Okay, next we're gonna go across the portage to the village of Ripley in Franklin Township and talk about flooding in the Ripley watershed.
So I'm Troy. I'm Rob.
And I'm Adam.
And this is the Ripley Creek Watershed Project.
So just like the other group, we looked at a lot of hazards in the Houghton County area, and mainly we focused on Father's Day flood in 2018. We looked at Ripley Creek, we looked all the way up to Lake Linden, and we ended up settling on Ripley Creek because we had interest from the Franklin Township Supervisor as into problems that were currently there. So some of the big hazards for this is there's only, specifically with the Father's Day flood, it washed out one of the main highways to actually get up into the Keweenaw, which was a huge problem. And then the creek itself also runs under and in between several houses on its way down next to Ripley. So we saw a lot of potential hazards dealing with personal property damage and loss of transportation, as well as cutting off the fire department that was right alongside the creek on the way down.
So when looking at this creek here, we looked at the stormwater management systems around the area and saw that there was a need for a better system. So we looked at the major issues of this, looking at directly the town of Ripley. Like Troy said, the creek goes under the houses there, and sediment can go into houses and yards, and major erosion could occur. And after speaking with the Franklin Township Director, we learned that there was beaver dams that were blocking the tributaries up near the top of Ripley. And then we looked at the road directly below the creek and decided that this was the biggest issue that we wanted to focus on due to, like Troy said, the lack of transportation that could go through this area. So people who are affected, so local residents and population, businesses and tourism is all affected. So the houses directly next to that could be washed out or eroded. And like Troy said before, the fire station is right below there. So lack of access from the fire station and erosion at the fire station directly could be affected. And then if this major road were to be washed out, emergency services would not be able to gain access to a large amount of the population over there, and evacuation routes would also be affected. And tourism would also be affected by this road as well, if they were in the area or trying to pass through the area at all.
So our first design solution that we came up with was implementing a detention basin just north of the fire station that currently lies there. This essentially would divert the water away from Ripley Creek in the event of a major storm. This would help that culvert essentially ease the amount of water that goes through there, so it would alleviate some of that pain. Part of this detention basin would have a riser, so when it has fills up with water, it actually runs through a pipe and would be directed towards the portage. Some of the problems that would arise with this detention basin are just basic inlet outlet clogging problems from sediment and buildup. Our next idea happened to be a retention pond, which unlike a retention pond always has water standing within it. So the idea was to direct some of the tributaries into the retention pond. So that it would alleviate some of the pressure that's on Ripley Creek, so it wouldn't have as much water flowing through at once. Part of the problem here with the retention pond is there's not a ton of space around the village of Ripley to actually place something like this. So we had to put it on the northern slope above the village, which could be a problem. Like Kate and Troy mentioned earlier, we spoke to the Franklin Township supervisor, and she mentioned problems with beaver dams and clogging of tributaries, so water couldn't flow right all the way to Ripley Creek. So one of our solutions happened to be clearing tributaries. There just isn't a lot of survey data or data available to really pursue this option, as it's not really known where these tributaries are and whatnot. So our final idea and solution happens to be a small concrete dam that we would place there in Ripley Creek. This would have a small orifice at the bottom to allow for a regular level flow and to only take in during high storm events. This dam comes with minor problems. If you were actually to implement it, it would really only affect the habitat around the area. That's about it. So here's our FMEA comparison of like before and after we would implement solutions for these design solutions. Basin overflows, detention pond overflows. The detention pond overflow would probably be, oh, no, retention pond overflow, excuse me, would probably be the biggest hazard, of which to like a solution to that problem might be like driving more piles, getting it more sturdy and able to handle the amount of water that they have there, that would be there.
So we came up with a rough cost estimate for each of the ideas to help us decide which was gonna be the best. So obviously the dam was currently the biggest cost just due to what the work would go into that. But we definitely weighed our options here, but it was a risk versus reward. And that's what really led us to actually continue on with the dam over the other projects.
So after we went through the brainstorming process, we decided to start the actual design process, and we started with ask. We asked our stakeholders their input and feedback on each of our designs and solutions, and see what they would think the best option would be. So initially, we were going to do the detention basin or retention pond, but after looking at the failure analysis and actually implementing either of those into a side of the hill would have been a lot more difficult and a lot more, had a lot more issues with it. So we decided to proceed with the dam design, and then we moved into our researching and imagine phase. We went out to the actual area where there's a natural valley where the creek goes through, and we looked at it and saw like where we could put the dam and stuff like that. And then we surveyed the area ourselves to get a more accurate reading of that area. And then we moved forward with our planning and creation. We did flow calculations in GIS software, and then created our actual design in AutoCAD Civil 3D. And then moving forward with our testing and improving, we couldn't really test our solution as of now, but looking at past reports and looking that this is still definitely an issue in that area, we think that implementing this would be a good solution.
So we are actually able to get our hands on a total station and prism poles from the surveying department. We weren't as focused with actually finding a corner and surveying all the way into the valley right here to make this. But instead we were able to go check and find the highest points and the lowest points within the valley right here to give us an idea of what kind of volume we would have. So we decided we were going to take a topographical survey so we could have an idea of the amount of water that would be held in this area should we construct the dam. And then we were able to make a surface in AutoCAD 3D reflecting our differences in elevations through here. So we were able to have a width of the valley and then the length and then where would be the best fit for the dam.
So using our survey data, LiDAR data, and referencing past reports on the Ripley Creek watershed, we move forward with our flow calculations. So we delineated the watershed in ArcGIS software and then got the area of that to be about 615 acres. And since the area of this is over 200 acres, we use the MGQ method to solve for the peak flow and got our peak flow to around 226 cubic feet per second.
So, now that we have our survey done, we could create this surface in AutoCAD. Got to see that we had about a 30-foot vertical height difference to work with within this kind of washed out creek bed. So to better understand also kind of what the surface is actually doing, we created an alignment that runs from north to the south, reading here on the profile left to right. So you can see we lose a lot of that elevation the closer to the portage we get. And again, you see out that 30-foot difference. The one main constraint that we have with the area to build with over here is this kind of is the area of the surface right by 3rd Street, which is kind of the main access point to our area over here. That elevation difference from the lowest point is only about 24 feet. So obviously we don't want to construct the dam higher than that and risk washing out the road if that dam does fill and overflow. So go to the next slide. So with that in mind, we can design our dam to only be 21 feet high so that if that does overflow, we've got about 3 feet of clearance so that the road hopefully won't be affected by that. We placed the dam at our lowest, farthest south down surveyed area so that we have kind of the biggest area to work with in terms of water storage. So to fit that widest downstream cross section, the dam's going to be about 120 feet wide, which gives us a 200-foot run of storage space back up to the kind of highest point north. We incorporated a rectangular orifice into the center of the dam that is going to basically run over where the creek naturally flows. So during normal conditions, that creek still is able to flow naturally. And the dam really only kicks in during flood events to retain that water and hopefully decrease some of the erosion that would happen downstream. To construct this dam with the dimensions that we have, it would take about 1,400 cubic yards of concrete. And then we also toyed with the ideas of excavating behind the dam to increase the total amount of water storage that we would be able to have. And the excavation that will be in the next slide that pretty much doubles our total volume of water storage that would be possible. So like I said, we graded the dam based on some of the references and research that we did. So you can see with the existing surface, which is in the middle, the completely white area would be the storage volume without any excavation. And then being able to excavate, we get kind of a pretty similar area. So without the excavation, with a 100-year storm event over the course of 24 hours is what we designed with. Without excavation, that dam would fill up, we estimated about 2.5 hours. And with the excavation, just over 5 hours it would take to fill, which greatly increases our time to evacuate anyone from the area and avoid any washed out roads. So even though the excavation does increase the costs for this project, we kind of felt that with double amount of time to save anyone from the area if necessary, we gave more emergency access, that was going to be a cost that we were willing to incur. So, like I said, I guess we felt that this was the best project, best way to implement this because, again, it keeps the natural flow of the stream during normal hours, doesn't really affect much, but the storm concentrations, which is what we were really looking at as the hazard for this area. It solves that pain point with making kind of a very little impact on the day-to-day use of the area. And with the risks of the other designs would require a lot more excavation into the hill of the area. And the dam kind of uses that natural slope that already exists to the advantage of that area, which is another reason why we think that this is probably one of the better ideas for the washed out creek.
So for our cost estimate, we determined it was going to be about $1.2 million to construct this dam with excavation, excavation actually being the largest chunk of cost to make this happen. But we determined that was worthwhile in the amount of time, like Adam said, for how much time that road would probably still be able to stay open, and how much time we would have for the storm to either end or get people out. And then we went into all sorts of other stuff, because we figured that we're gonna have to do a little bit of land clearing. And then something we haven't really touched on much is we were to prevent clogging on that orifice. We looked at putting a steel grate to prevent any large objects from coming in. And it would also make clearing out a clog easier, instead of having it be in the center of the dam, it could be on the outside of the dam to wipe it away. And then just some other small costs associated, but the biggest cost and benefit was going to be to do all of the excavation for the project.
Any questions?
So was that peak flow you calculated the expected flow in a storm or the peak flow that the dam can handle?
That was expected in a storm, so we looked at the 100-year, 24-hour storm, because when we were doing research on dams, that was the standard design storm for a dam.
Yeah, that had to stay the same over the future.
The 100-year storm.
Yeah.
With the frequency that we've had large storms around here, having a 1,000-year, a 500-year, and then I believe there's another 500-year storm not a year or so after, or something like that. Between now and then, there was another big storm. I would expect that the 100-year storm is actually probably going to go up, looking at the frequency of the storms we've been getting.
So if this were to be implemented, that would definitely have to be taken into account of future peak flow events.
You design any kind of overflow?
Not currently, no. We designed the rectangular orifice at the bottom that would allow for flow through, but not at the top doing an overflow.
You need something like that?
Yes. Yeah, we looked, and there was a lot of different approaches we saw, but none of us were super familiar with the dam process. We did see that in some cases they put one towards the middle, and they put one a couple feet from the top. And we were having trouble trying to figure out where exactly to put that and find references as to where to put it, because we weren't sure on the actual design specifications for that specifically. So that would have to be something added in as we go.
So dams would always have some kind of an emergency spillway, right? So you don't ever want water to go over the dam. You want it to maybe go around into some side channel. But how do you know, given your runoff, that the dam won't be overtopped or won't need to go into the emergency spillway? Did you do like a hydrograph analysis, like route the hydrograph through the storage basin?
So with the constraint of the time for our project, we did not get that far in that part of the dam design, but it would have to be done, yes.
And in terms of adding a spillway, the western side of the area is backed up against the ski hill, but the kind of two runs of that ski hill that are closest to the creek were like totally washed out with this flood and haven't been like reused for skiing. So there is some area that we could clear over there, provided that Ripley doesn't have any current plans plans to re-implement those ski areas. And since it's been quite a few years, I don't think that there are any current, plans to re-implement those. So it would give us a little bit more area to work with in terms of clearing out and, potentially having more storage or that extra spillway if needed.
You need to go up and look at that,
Okay.
who's doing the ski?
Oh, we were right at the base of where they were, putting all the fill back in to rebuild it back up.
I suspect they're back on it this year.
So the area is pretty steep and you have a water volume problem and a water velocity problem, I would imagine, and for the erosion in that area.
Yep.
Does the dam help with one more than the other?
So the goal was to, create the most amount of time for anyone down there. So the big thing was the velocity problem going through that creek is, a little ways down from where we actually were doing our survey. The creek dips underground and goes underground between several houses. And that was a big problem during the flood, is that creek actually collapsed a bit through there, leaving those houses in a very poor state. So we wanted to be able to regulate the velocity, and which was going to create a volume problems, because we didn't want it to just erode out the rest of the creek all the way down and wash out all the houses and the main highway. So that was our main goal, was to decrease the velocity, but that was going to create a problem of holding volume for us. If that answers what you're.
Thank you.
Thank you.